So here is question 3, and just like the other questions, we have to figure out if we need Kirchhoff's current law, and we need Kirchhoff's current law if there is a current source in the circuit. There is a current source in this circuit. Unfortunately, it has two of the mesh currents going through it. It has, on the left-hand side, it has I1 going through it, and on the right hand side it has I2 going through it. So we can't get a freebie out of this one. We have to do a little bit more work to get this one to happen. But let's have a look at it. Okay, so in this case, now we have to start thinking in terms of a super mesh. So we have to find a mesh that includes most of the elements of I1 and I2, but does not flow through the current source. The reason is because if we're applying Kirchhoff's voltage law, we don't know the voltage across the current source. We only know the current it supplies, we don't know the voltage. So I'm going to suggest that if that's IX, that we do a super mesh around like that. Okay, and now we can in addition to the mesh current for the mesh equation for I3, the Kirchhoff's voltage law equation for I3, we can do a Kirchhoff's voltage law equation for this super mesh, and then the Kirchhoff's current law equation is going to be for IS and the currents flowing through it. So the first part asks for the super KVL. So let's do the super KVL, super Kirchhoff's voltage law. And I'm just going to run through it. So this is going to be a plus and a minus and a plus and a minus, and this one's going to be a plus and a minus, a plus and a minus. So looking at that, we have VR1 plus VR2 plus VR3 plus VS equals 0. Okay? And we can rewrite that as I1 R1 plus R2 times I1 minus I3. Right, I3 is going in the opposite direction to I1 through R2. And then VR3 is going to be R3 times I2, also minus I3. And then the voltage source is, well, we can just put that on the other side. Pulling that out, we get R1 plus R2 times I1, R1, so that's 17 I1, plus, and then I2, we just have R3, so it's 9 I2, and then I3 is minus R2 minus R3, so minus 18 I3, and that equals minus 11. But I just left it in the everything on one side, 0 on the other version. So that gets the super KVL. The KCL equation, right, is basically we have I2 is flowing in the same direction as IS, so it's going to be I2 minus I1 equals IS. Now the tricky part is that IS is a dependent source, and it's going to be 4 times IX. So IX is equal to, it's over here, right? So here's IX in here, So Ix is I1 minus I3, and it's going to be 4 times. So Ix is I1 minus I3. So Is is 4 times that. 4 times I1 minus I3. Okay, and that's where I got that equation from. And then the last one is the I3 mesh. So the I3 KVL equation, back to Kirchhoff's voltage law. And there, let's just put some polarities on there. So that's going to be VR4 plus VR3 plus VR2 equals 0. And VR4 is just R4, which is 9 times I3. VR3 is 9 times I3 minus I2. Right? And VR2 is 9 times I3 minus I1. And that equals 0. And that looks pretty much like what I got before. And now we have 3 equations in 3 unknowns. I'm just going to rewrite the KCL equation a little bit, right? So we've got minus 5I1, right, plus I2, plus 4I3 equals 0. And now we should be able to fire up MATLAB again and put those numbers in. So let's just do another one. And this is going to be homework 3Q3. Right, and my A matrix this time is 17, 9, minus 18, and then minus 5, 1, 4, and then my I1 is minus 9, and my I2 is also minus 9, and my I3 is plus 27. And then the B, we just have a minus 11, and then everything else is 0. And then Q3 I's equals RF AB, right? And then we just want to do something like that, and it should be I3, and that looks like the numbers I got before, minus 0.7, minus 1.1, minus 0.6, all good. And then the tricky part is, what's it asking for? It's asking, I believe, let's just go back to the question, because I didn't, it's asking for what Ix is, right? And that should just be, well, we wrote it up here, Ix is I1 minus I3. So I1 minus I3, so it's minus 0.1 amps. Okay, I'm going to kick with this video and do another one for question 4.